Okay, this is today's video. It's part 2 of the IGCSE Physics Paper 1 from November 24, so it's a very recent exam. I went through part 1 yesterday and you'll find it in the same playlist. If you haven't watched that, you may want to go and watch the first 8 questions we covered yesterday. And thank you if you've liked and subscribed. Today the channel has been monetized, so you can also become a member of the channel. I think you get some perks. I don't really know what it's all about, to be quite honest. I just followed the instructions on the screen. Okay, I think you get like priorities for if you've got questions, then I answer them more quickly. Okay, well anyway, let's get straight into part 2. So this is a question that a paper I gave my students to practice, and they're taking the exam obviously this summer. A student investigates different electrical components. Okay, it's a very, very common type of question, and the circuit diagrams are more or less the same each time. It says the student first investigates how the voltage of a diode affects the current in it. Okay, so a diode has a symbol which looks like that. So first of all, you need to make sure you know all your basic electrical equipment. So here's the list of equipment they want you to use. The diode, the cell, a unit of a battery, the variable resistor, and the variable resistor allows you to vary the voltage that the diode gets. So you put it in series with the diode. Okay, so when the arrow indicates that you can vary it. So the arrow is the crucial thing on the resistor. So a normal rectangle would be a resistor. A resistor with an arrow in it is a variable resistor. Wires are just simply drawn as straight lines. Voltmeters, hopefully you know, they're always in parallel, and they need to be in parallel in this case with the diode, because the diode is the component you're testing or investigating, and the ammeter measures the current through the diode, so the ammeter is always in series with the component. Okay, all right, so first thing they want you to do is to draw the circuit diagram, that the student could use. Okay, so circuit diagram represent a circuit they could use. A diode has been drawn for you, so they weren't sure that you knew what a diode looked like, so they're giving you the diode, and you've got to put all the correct symbols to get 1 mark to show that you know the symbols. So I've already discussed that with you. So the ammeter, the cell, and so this is the cell and the variable resistor, all in series with the diode, and then the voltmeter must be in parallel. Okay, and that's basically it. And then the other mark is for putting the ammeter in series, so all the circuit symbols correct, and the variable resistor in series. Okay, so that will get you 4 marks where I put the ticks. Okay, in the second investigation, the student uses a circuit with 2 resistors, okay, A and B, you can see them in the diagram, and a battery, which is 2.9 volts. So battery, so this was a cell, and when you have 2 cells like this joined together with the dotted line, it means a number of cells, which we call a battery. So battery has this symbol, okay. So 2.9 volts is the value of the potential difference that it can provide, and the diagram shows the circuit and the current in each resistor. Now you can see the current in resistor A is 0.15 amps, and the current in resistor B is 0.23 amps. That means that B is allowing more current through, although they have the same voltage. So if it's allowing more current through, that means that B must be a lower resistance. So the resistance of B and the resistance of A can be worked out because both of them have a voltage of 2.9 volts. Things in parallel, yeah? So the two resistors are in parallel. The voltages in parallel are equal. So the voltage 2.9 will be equal to the current in A, that will be IA times RA, and it will also be equal to IB times RB. Okay, that's just using the voltage equation. Okay, so that's just a preliminary understanding of circuits. It then says calculate the current in the battery. Yeah, well, the current is the total current when you join the two together. So the two currents will come through, join up, double up, and become the current that goes through the battery. Okay, so the total current is IA plus IB. So this would be IA, and this would be IB. Okay, so you add those two together, and it's as simple as that. Okay. It then wants you to state the formula linking voltage, current, and resistance, which is what I did here to show you that the two things in parallel have the same voltage, and you do the same again. And you can see the way I'm saving time by just pointing arrows to the words. The standard way in physics is to write a word equation. Okay, but I think this would be a shortcut, and I haven't seen examiners in Edexcel, IGCSE, take away marks for not writing the word equation if you use the correct symbols. And if you don't know how to change the subject of the equation, I've put it in a triangle for you, yeah, because they want you to calculate the resistance. So you've got to change the equation round to make the resistance the subject of the equation. Basic algebra, then put the numbers in. 2.9 was the volts, and the current in A was 0.15. So you put that underneath and you get 19.3 ohms. If you do it to three significant figures, but really you should only answer to two significant figures, because all the data provided is only two significant figures. They won't penalize you if you put three, okay? But that's how you know how many significant figures to put. The next question, or the next part of the questions, has diagram 2 shows the same three components. Yeah, the 2.9 volt battery. Resistor A, which we just worked out, has a resistance of 19 ohms to two significant figures, and resistor B, and we haven't worked out his resistance. This time they're connected in series. Yeah, so this is a series circuit, and in a series circuit, this is the rule. Yeah, the rule is that you add the resistances. So two resistors in series increases the resistances, and two resistors in parallel decreases the resistances because you get more flow through two paths. Resistance B, it says, has a resistance of 13 ohms. So they're telling you what RB is, and you just simply add the two and you get a total resistance of 32 ohms. Okay? Now they haven't asked us to do that, but I'm just showing you how series circuits work. Okay? So comment on the difference between the current in the battery in diagram 2 and the current in the battery in diagram 1. So we know the current in diagram 1 was 0.38, yeah, it was 0.38 amps. You can go back and have a look. And now you have to use calculations to support your answer. In other words, they want you to work out the current in circuit 2 or diagram 2. So the total current will be the total voltage divided by the total resistance. And I've just told you that the total resistance is 32. So you put 32 into this equation. We know the voltage is 2.9, so divide one by the other, and you see that the current is much smaller, yeah, only 0.09, because I told you two resistors in series adds to the resistance, so the current is reduced. Okay, so you've got a comment on it then, and it says a total current in diagram 2 going through the battery, obviously, is much smaller, or a quarter, as shown above. So about a quarter, just under a quarter, because two resistors in series increases the total resistance, as I explained, and I've shown that I know the equation for it. And that whereas two resistors in parallel reduce the total resistance, okay? So the battery, when the resistors are in series, will have a lower current going through it, okay? Now, I'm sure I will get the 4 marks by putting that there, but let's have a look at the mark scheme. You can first of all see 9A, the circuit diagram, and the notes that they give you about what they will accept, and you can read through it in your own time. Stop the video if you wish to. Part B, the current in circuit A, we got it right, and the current in circuit 2, I've added it in for you. Yeah, I just didn't want to include the 1 or 2 points that they've done on the next page to save space, okay? So they want you to say, calculating the resistance in diagram 2, which I showed you is 19 plus 13 equals 32. So if you've shown how you got that, you'll get 1 mark. Then the idea that the resistance is larger in diagram 2, commenting on it, and the calculation of current in diagram 2 to give you a bit more detail, and then the conclusion, so the current is less in diagram 2, will get you the 4th mark. Okay? The next question is question 10, and it's about energy transfer by conduction, yeah, in different metals. So you can see they're using iron, steel, aluminium, and copper. All right. So the student uses wax to attach 1 coin to each of the 4 different metal rods. So I did a very similar experiment this week with my year 10s, as they've just started the energy topic, and they connect the rods to a heater. The heater is in the middle, equidistant from the start of each of these rods. When the heater is on, heat energy is transferred through the metal rods by conduction. Okay, so remember, conduction is vibration of the particles in each metal, layer by layer, passing on the vibrations from one layer to the next. This melts the wax when the temperature gets sufficiently high at the end, and causes the coins to fall. Okay, the diagram shows the equipment viewed from above, so you can see the length of each of the metals, yeah, and these are representing the coins on the end of each one. Same coins, same size, yeah, but something isn't correct if you look at the diagram in terms of validity. So this is the student's method, it says. Step 1, switch on the heater and start a stopwatch. Record the time taken for the coin to fall from each metal rod. Okay? Give the independent variable in this investigation, or the independent variable is the different metals that you've used. Okay, you're testing the different metals, so that will be the independent variable, the metal or the material used. They'll accept either. And give the dependent variable, what do they measure as a result? They measure the time taken for the wax to melt. So you've got to put that in to make sure the examiner gives you the mark. Don't leave anything to the imagination. Okay? It then says the teacher who's supervising the students tells the student that their investigation is not valid. In other words, it's not a fair test scientifically. Give 2 ways to improve the validity or fairness of the student's investigation. All rods must be the same length. You saw that one of them was much longer than the others, and they must all have the same thickness or diameter. And I think that is the best 2 points to make to get the 2 marks. Okay? What else can you include? We'll have a look at the mark scheme. There are alternatives that they will give you credit for. The student improves the validity of their investigation, presumably by doing something as I've written, and then describe what the student should do now to improve the reliability of their results. So reliability is not the same as validity. Validity, making it fair. Reliability is trying to get a more precise result, mathematically or numerically. So you should repeat it more than once, and you do what's called an average to calculate. The type of average we want is the mean. So you want to calculate the mean. Repeat an average to calculate the mean average, okay? So technically, repeat and calculate the average would get you the 2 marks, okay? So reliability is checking that each time you do it, you get a same result. So there's no anomalous data in there. Like it didn't just fall off by accident, the coins at the end. Okay, so that's another question. Question 10, we've talked about that. Here's the alternatives that they accept for the validity. Same length, rods the same thickness, yeah, different words. Coins must all be the same mass or the same type of coins, ideally, yeah. And same mass or amount of wax used. That's a good point too. Yeah, so these are all controlled variables to make sure the experiment is fair. Okay, and then the reliability is repeat, calculate the mean, the time, mean time for each rod. Okay, don't just do it once because maybe there was a reason, maybe there was vibration and one of them fell off, etc. So you repeat and take a mean. Okay, then they want to make sure that you've got a suitable graph in the next question. So we're going to have a look at that, and you can see just by looking at the mark scheme that the graph used is a bar chart because the metals are not a continuous variable, they're just different categories of material. Okay, so when it's a non-continuous variable, yeah, we call it a categoric variable, then you would use a bar chart. Okay? So non-continuous variable. In other words, you can't make a number from it. Okay? So here's the data they give you. The table gives the students results. They want you to plot a bar chart, so they tell you to do bar chart. And I've just shown you the mark scheme and their bar chart. So you've got to copy that as well. You've got to make sure you've got a suitable scale on the y-axis. Yeah. So going up in 50s would be a suitable scale because it goes up to a maximum of 230. Yeah. So you've got to make sure you go up in a scale which is easy to use. So we say multiples of 1, 2, or 5. Okay? So then you've got to label both axes, and obviously you need to put the units for these numbers here, which I haven't done, but you need to do. And obviously the type of material has no units, but you still need to make sure that you have labeled it before you put your bar chart. And then the third mark would be that you got all of the bars to the correct height, and the examiner will check that. So you will end up with steel being the highest, then iron, then aluminium, and then copper. So what does that mean? The lowest one is the shortest time taken. That should be the in seconds on average, the time taken to drop. So copper was the lowest value. So copper is the fastest. So copper is the best conductor. Then aluminium. Okay. State why a bar chart is better than a line graph. Well, you can't really use a line graph because the data is discrete. Yeah. The type of metal is just different categories of metal, and it's not a continuous variable. Okay. I would put both of these points to make sure that the examiner knows that you understand what a discrete variable is, or a categoric variable. Okay. That's 10 marks done, and we're coming towards the end of this paper. Question 11, it says, which of these is the main source of energy in stars? That's just knowledge. Energy in stars comes from nuclear fusion. Yes, so the answer is D. Okay, so fusion means joining of small nuclei, and when that happens, it releases energy. The table lists the stages of development of a star that has a very much larger mass than the sun, and they want to give the stages in the correct order using numbers 1 to 5. So I've put number 1 first. When the core of the star runs out of hydrogen, what happens to it? It will become a red giant, but because it's a much larger sun, it will become a supergiant. Yeah, so that will be number 2. Number 3, heavy elements can then be formed in the core of the star during the red giant phase, and then when it runs out of fuel completely, the star will explode due to a drop in pressure, sudden drop in pressure in the center. So it sucks itself back into the middle. As the temperature drops, the pressure will drop, so it pulls in the outer layers of the star, and that causes a bounce back, if you like, and that is the stage where you got a big explosion, and that's called a supernova explosion. Okay, so 4 is a supernova explosion, and if it's a very much larger, so it says very much larger, then there is a possibility that a black hole is formed from the implosion in the explosion. So a supernova kicks out the outer layers, and the inner layer, the inner part of the star, then becomes very, very dense. And for a black hole, the density is such that even nuclear material cannot withstand the gravitational forces, and they collapse into what we call a singularity. And a singularity is technically almost a zero volume point. So a singularity means a point volume. So all that mass, which was a very massive star, gets sucked into what we call a black hole, and the matter disappears, and it's kind of like a gravitational energy void. Yes? So it sucks anything that gets close to it in it, and recycles matter into pure energy. And that comes to the exciting equation of E equals mc squared. So all the mass gets converted to energy, and we don't know what exactly that implies. That's 110 marks I've gone through. The last question is 5 marks, and if you found that useful, don't forget, you can become now a member of the channel, and if you then have queries, you'll be prioritized, because obviously we now have almost 1,200 subscribers. So if there's lots of questions, the people who are members will get priority treatment. And if you want to be a subscriber, if you're new to the channel, that would be great. And don't forget to like each video, to show your appreciation and to help the channel offer more support in the future to students like yourselves. Thanks for watching. Catch you next video. Bye for now.